Okay. Conditional probability. Got that? Conditional probability. Are you ready, Albert? Good. Okay, so if you remember last week, was it? I think we talked about the meaning of this symbol. How do we read this symbol here? Yeah, knowing that or given that, yeah. This is an example of what's called conditional probability. It's the probability of A if you know B. So we've looked at this a little bit last time. Okay. How did we calculate these last time? Do you remember the example we had was what's the probability that you have the disease if the test was positive? Remember that? Or the example, probability that the TV was made in China if it was broken, for example. Do you remember this? So how did we calculate that? What did we do last time? We did a table. This is not the best way to do it. We actually have a formula we can use to calculate this. So the formula is, if we want A, given that B has happened, it's the probability of both A and B happening together, divided by the probability that B would happen. This is a formula to calculate conditional probabilities. And the formula makes sense if you think about it as a set. So we have A and we have B. So when we say B has happened, that means we are only in this set. True? And when we want probability that A will happen, that leaves only this possibility. So it's not too surprising that the answer is this number, which is on the top, divided by this total, which is on the bottom. It's like what you want over the total. A similar idea. Now the proof is not on the course or the exam, but I just wanted to give you a quick explanation of why this formula makes sense. But if that doesn't make sense, that's okay. This is the formula you use to calculate conditional probability. Okay?
Do we have it in the formula?
I think not. I think no. I'm not 100% sure, but if they do have it in the formula book, it means maybe they added it in recently. I don't remember seeing it there, so I think, yeah, you want to remember this one. Okay. Let's have a look at some examples here. Maybe we can go back to the example we did with the test, the positive, negative disease. Can I go down? Yeah. So we have a test, and the test will give you a positive result given that you have the disease. So this we said was 99%. The probability the test will be negative given that you don't have the disease, that is 0.99 as well. And then we also said, what's the probability of having the disease? I think we said only 1% of people have the disease. And we want to calculate what's the probability that you will have the disease given that your test result was positive. So this is the probability of the disease and positive over probability of positive. Now, the way you would need to do that is you need to do it as a Venn diagram, as a set. So what you could put here in this one is if you have the disease or if you don't have the disease, in or out. And then this set is if the test is positive or if it's not positive, which means negative. So we need to try and fill in the numbers here. So remember the little trick we had last time was we'll call this piece here X. How big should this piece be?
X minus
Number minus X. What number? 0.01 minus X. This one here, can we calculate it? Do we know how many people will be positive? No, we don't, do we? So what we can do, let's see if we can make some formulas here with this. So if I want, I need to make some space. Let me get rid of this for a minute. Let's just forget about this for a moment.
Where is done?
Huh?
Where is done in the chapter?
Where's what?
Done.
Don't what? Don't have the disease?
Yeah.
Anybody outside of this circle doesn't have the disease. Yeah. Okay, so let's look at this first one here. This is saying the probability of having the positive test result and having the disease over probability of having the disease is equal to 0.99 using the formula I gave you. Okay. Now that's actually really good because we know this number. Do we know this number?
Yeah. No.
We do actually, because I give it to you. It's 0.01. So we can work out the X in the middle. So I don't even need to write the X. I can get rid of it and put the number in. Right, so I hear somebody already typing there. 0.99 times 0.01. So this gives me probability of the disease and positive test result 0.0099. Now I'll try and fit that in here. 0.0099. So do we know this piece here? Yes, we do. It will be 0.01 minus 0.0099. So here, this piece here will be 0.0001. What's wrong, Albert? You missed the last class. This is what's wrong. Okay. Next, now, let's have a look at this one here. So this one says probability of negative and no disease divided by probability of no disease equals 0.99. Now what's the probability of not having the disease? 1 minus this, which is 0.99. So you can now get probability of negative and no disease will be 0.99 multiplied by 0.99. And you get 0.9801. Where is that on my Venn diagram? So these are negative. So these are people without the disease. So you must be outside this circle, disease-free. And also, disease-free and also negative result. So where's negative result? That's outside this circle, isn't it? So there's only one place where you can be outside both circles, and that's right here. This is no disease and no positive test. 0.9801. So can we get the missing number here? We can, because what should the total be? 1. So if I hit that out on the calculator, we get a very small number again. 0.0093 3. So any question you could have for me, I could answer it. I could say, how many people will be positive and get a positive test result? How many people will be whatever negative and get a positive test result? You can answer any question here about this now. What did we say was the worst situation? The worst situation is that somebody has the disease and what? Negative result. So that would be probability of negative and, or not, given that they have the disease. So that would be probability of negative and disease over probability of disease. Okay, I know what the bottom is. It's 0.01. Negative and diseased. Which number is that here? Negative and diseased. Which of the four numbers is that here?
0, 0, 0, 1.
This one here, isn't it? This is negative and they have the disease. 0.0001. Okay, so let's see what this 0001. What's this? 0.0001 divided by 0.01. Do I have enough zeros? 000. Yes, this is it, isn't it? So this is 0.01, which is 1%. So this means that 1% of people that have the disease will get a negative test result. So if you have 100 people who have the disease, 99 times it will say you have the disease, but there's 1% of the time where you get a negative test result, even though you have the disease. It's known that you have the disease. Okay. So we can use this conditional probability formula to help with our calculations. Let's have a look at some examples. So let's have a look at question 1 here. Okay, can I scroll down? Yeah. The probability a student takes the bus to school is 0.8. So I'm going to look at this as two sets again. Bus. Okay. The probability that the student will be late for school, so they can have bus and being late. Right, so we know the probability that a student will take the bus is 0.8. The probability that they will be late is 0.2. And finally, the probability of the student that takes the bus and is late. So the probability that somebody takes the bus hang on. Yeah, take the bus and late is 0.1. And my question is, what is the probability that a student took the bus given that they were late? So here we have a student who is late, and you want to know what's the probability they took the bus. Yeah, we can calculate. So let's try and fill in the numbers. Which number do I know straight away? This one here, isn't it? What's this one in the middle? 0.1. And so what must this be? 7. See what happens when you are asleep? And what's here? 1. And what's here? 0.1. What does this represent? These are people who... No. No. They do not take the bus and they are not late. What are these people here? Late. Don't take the bus but they're late. These people here? Take the bus and late. And then take the bus and not late. So we want probability that they took the bus given that they were late to class. So this is probability of bus and late over probability of late, which is 0.1 over 0.2, which is a half. So if somebody is late, there's a 50% chance they took the bus. Okay. Right, so write this one down. This is number 1. So my answer is wrong, of course. Well, no, I think this answer I wrote at the back is wrong, of course. So I need to fix that. Yes, I'll have to do that later. Right. Let's have a look at another example. Can I go down? Yeah. Number 2. So a teacher will either have tea or coffee for breakfast. So we'll call this one tea, and not tea means coffee. The teacher will also choose to have toast with butter or without butter. So we can have them with butter on their toast or with no butter. The probability that the teacher will have tea and buttered toast is 0.1. The probability that the teacher will have tea is 0.5. So what do I need to put here? 0.4. What else are we told? The probability that the teacher will choose to have toast with or without butter is also 50-50. So here it must be 0.4. So how many times will the teacher not have tea and not have butter on the toast? 0.1. Okay. So from reading the question, this is the information. What is the probability that the teacher will have tea given that they did not have butter on their toast? So you know that their toast has no butter. What's the probability that they will have tea? So that is tea and no butter over no butter. 0.1 over 0. What's this one here? No butter. Well, what's butter? 0.5. So no butter is also 0.5. So the answer here is 0.2. Yeah? Also wrong.
Tea with no butter, why is there 0.1?
Is it not? Oh my goodness, it's not. Okay, sorry. Hold on, I'm hungry. This is the problem. Tea and no butter is this one. Thank you, Tony and company. And no butter is 0.5, so it should be 0.8, which is much better, because that's what I have at the back. Okay. Right, I'll do one more, and then I'll let you try some, okay? So, number 3 now. Can I go down? Yeah? Right, so in number 3, you have a student who can study maths or not study maths, and then a student who can study physics or not study physics. So your choices are maths and no maths, or physics and no physics. Right, let's read it. 70%, let's see, right, the probability that a student will study maths is 0.6. The probability that they will study physics is the same. So probability they study physics is also 0.6. 70% of students study maths or physics. So maths or physics is 0.7. What is the probability a student who studies physics also studies maths. So the question is, what is the probability that they study maths? If, yeah, now because I said also, it means like, because I said what is the probability a student who studies physics, so you know they study physics, also studies maths. Okay. If I call this x, what must this be? 0.6 minus x. And this one here? Yeah, 0.6 minus x. So if I add them all up, here should be 1 minus all of this. So that plus that is 1.2. They cancel with a minus x. Is that right? So it should ends up being x minus 0.8. Yeah. Anyways, I don't need to do that. I think this is the one here that will be helpful, because I can say this plus this should equal 0.7. So let's see what we get. 0.6 minus x plus 0.6 minus x should equal 0.7. So let's get the x. 0.7 minus 0.6 minus 0.6. 0.5, but there's a minus and the minus is cancelled. Yeah, so you get x equals 0.5. That's great. So that gives me everything I need. So here, this is 0.5. So then what's this piece here? 0.1. And this piece here must be 0.1. So this piece here must be 0.3. Alright, so probability that they study maths, given that they study physics, so that would be maths and physics over physics, which is 0.5 over 0.6. Oh, thank goodness. Oh, it's just the first one that was wrong. 83%. 83%. So there's an 83% chance a physics student will also be a math student. So if you have a physics student, there's an 83% chance that they will say they study maths. Okay. Right. I think the best thing here now is practice. So what I think I'll do is I'll let you try these for a few minutes, and then we'll do the other lesson as well. And there should be still a little bit of time left at the end. We can do more practice questions, or you can just practice more questions. Again, I do want all of these finished, because you don't have any questions like this on past exams, okay? So I've just done 1, 2, and 3, so you can start from 4. You can do this for 10 minutes, and then we'll start the next lesson at 10 to 1.